welcome everybody. Thank you very much for coming here. So this is the final installment in this very nice series of discussions that we've had with our alumni. This is in celebration of the 50th Jubilee of Material Science and Engineering at the U of M. So a very nice occasion for us to do this for. So what we have today is we have a panel of 4 alumni from the department, some with PhD degrees, some with undergraduate degrees in material science. And the theme here is that they are all currently in academia or in national labs. These 4 individuals are just going to introduce them very quickly, just in alphabetical order, and then I'll ask them to say a little something about themselves. But they are Dave Barr, PhD in materials from '97. I hope you don't mind me saying that, Dave.
Yeah, it's fine.
Who is currently at Purdue. In fact, he's department head at Material Science and Engineering there. And then we have Jamie Grunland, PhD Material Science and Engineering 2001, and he's on the faculty at Texas A&M. And then Todd Huber, undergraduate Bachelor of Material Science and Engineering in 2016, who's at Sandia National Labs, and then also at Sandia National Labs, Erica Redline, PhD Material Science and Engineering in 2011. So in whatever order that you would like, maybe you could just introduce yourself, say a few words about your career path up to this point, just a few words of introduction. And I should mention, by the way, for everybody's knowledge, that we are recording this, okay? So please go ahead. Maybe Dave, you could kick us off.
Sure. So thanks for joining us. As was mentioned, I'm currently the head of materials engineering at Purdue. The way I got here was I moved here in about 2012. Prior to that, I was at Washington State University. For those of you familiar with Washington State, that's the university that's 8 miles from Idaho, not the one that's in the area that has coffee and rain. And prior to that, I spent a little bit of time at Sandia, the other Sandia, the little version up in Livermore, while I was finishing up my PhD at Minnesota. Prior to being at Minnesota, I was at Purdue for my bachelor's and master's. So my path towards a department head job started off, Sandia was a really good way to start on learning about research. It also taught me that I probably wanted to be a faculty member. Not that there's anything wrong with being at Sandia, but I realized I really liked working with students. And so I went off to go be a faculty member. I got interested in undergrad research, started running undergrad research programs like RU sites, then started running multiple sites on campus, then became the university-wide director of undergrad research, still was doing experimental research, eventually became department head for mechanical and materials engineering at WSU. And then I moved to Purdue to be department head for materials because of the challenges of having to juggle 2 degree programs in one was just a little too much for me. And your current department head does that much better than I was able to do that at WSU. So along the way, my background in research has been I do mechanical properties, I break things. So I like to study material reliability, and I am material agnostic. So I'm as happy to indent or poke, prod, break, and snap explosives or human eyeballs or metallic foams or carbon nanotubes or, metals or semiconductors. So that's a little bit about me and how I got here.
That's great, Dave. Thank you very much. Maybe we'll go to Jamie next.
Yeah, so anyway, thank you for inviting me. I guess we had 3 questions to answer. And the first one was like, how did CEMS, or am I only talking about my career path at this point?
Yeah, if you could just give us an overview, and maybe we'll get to some of those questions later and we'll see what other people have.
Okay. Yeah, so I got my PhD in 2001. I think that's what we said that already, in material science. Yes. And I don't know how many students are in material science or how many are in ChemE. I guess it's a mix of both, right?
Yeah, it's a mix, and it looks like we have undergrads and grad students alike.
So, but yeah, so no, yeah, so after I graduated, I didn't expect to be a faculty member. I thought I'd be the CEO of a Fortune 500 company or something like that. And so I went to go work in industry. I worked for a company called Avery Dennison. There's been a number of, it's kind of like a baby 3M. So there's been a ton of CEMS people gone through Avery, and I still interact with a lot of former Minnesota people at Avery. So if you get a job offer there, that'd be decent. So would 3M, so would a number of other places for industry. But for me, the industry acted almost like a postdoc would for most people. I was only there 3 years. But I did get exposed to a lot because I was in central R&D in Pasadena, California. So that's not a bad place for a postdoc, a high paid postdoc because I was an industrial scientist. And just after a couple of years, I literally, to supplement my income, I was house poor, like a lot of people are in California these days, and even 20 years ago when I was there. And so I started teaching part-time at Azusa Pacific, at Biola University, and Pasadena City College almost. I had signed a contract with Azusa, I think, before them. But the more I was on college campus, I just started enjoying it more than I was enjoying, I guess, my everyday industrial life. You take that for what it is. That's just my prima donna personality or whatever you want to call it. And so I started applying for jobs. It is, I don't know if the landscape has changed, but there are, 100 or 200 or 300 people are applying for the same job you're applying for. So I actually didn't expect to even get the job, but I had been publishing while I was in my industrial postdoc, if you want to call it that. And so that probably helped. Publishing is important. And so I got the job at A&M, and that's my whole career path. I'm one of the weird people so I've been at one school now I'm in my 17th year. And I don't know how old I look because of my gray facial hair, but anyway, I'd be considered young, I think, for where I'm at. I'm not a department head or anything. I just got a chair, so I'm a chaired full professor. For 6 years, I've been a full professor. I can't believe any of those things. I'm not saying those things to brag. I'm saying those things in disbelief. Like, how did this even happen? I can't believe it, truly. But I'm blessed. I'm a very blessed man. And so yes, I am a CEO of a company of like 5 to 10 people, depending on how my funding is going, because all of us run a small independent little company. I do coatings, water-based coatings. I'm probably most known today for flame retardancy. If I get to be National Academy, it'll be for fire, I think. But I do gas barrier and other functional, but it's coatings. It's all thin film. So I do rely sometimes on nano-indentation people to help me with mechanical, which I consider myself more transport properties than mechanical properties. So I'm measuring gas transmission and thermal properties and things like that. But anyway, I have a fun, very stressful life. So that sounds like an oxymoron, or I don't know, but it's a good thing. So yeah, there's my path.
Okay, very good. Thanks, Jamie. So maybe we'll go alphabetically and we'll have Todd next.
Sure, yeah. So my name's Todd Huber. I'm at Sandia. I've been here for 4 years, and my career path, I don't have a PhD, I don't have a graduate degree, but when I was looking for jobs post-graduation, the national lab scene was never really made aware to me, and I actually found them through just my own independent searches, particularly Glassdoor.com had a lot of postings at all of the national labs. And that was not to like plug them, but that was a very useful site for the information they provide, interview information and job expectation and stuff like that. And so I ended up taking the job and kind of realizing how unusual my path into the national labs was as a technologist, not as what they call a member of technical staff. I became really more interested in like the recruiting side of things and making more students aware that these jobs do exist. One of my colleagues, when I was hired on, had been with the company for 37 years, and he was a recruit out of a technical college in New York. So at the time, he had a 2-year degree in, what might be called like an engineering principles type degree now. And in his 37 years at Sandia, had accumulated just a massive wealth of knowledge. But nowadays, with the competitive, the job market being what it is and education being where it is, they have expanded the technologist position. A lot of people confuse it with the word technician, which is kind of a point of frustration at times. But as a technologist, we are kind of like the associate engineer level position that you would see in like a private industry job listing. And depending on your group and your role, like you can be highly autonomous and acting as an associate engineer on a project. I've been at Sandia now for only 4 years, and there are several of my main projects involve only me in my group, and so it's kind of interesting when someone comes to me with an urgent production issue. They're not necessarily aware of how packed my schedule already is. And today has definitely been one of those days, but I'm glad to be here talking with all of you.
That's great. And Todd, can you give us, an example of the kind of projects that you work on?
Sure. Yeah. So our lab, we work in a group called Materials Mechanics and Tribology, and so we're sort of split into 3 labs, and we colloquially call them the tribo group, which is the tribology group, and they do coatings and characterization of those types of materials. And then the brittle group, which primarily does ceramics and glasses. And then our group is called the ductile group. So we do primarily metals, but anything with a sort of a ductile response. I'd say a significant portion of our work actually involves spring characterization.
Mm-hmm.
Because springs, for as simple as they are very mechanically robust, and they can be built into systems that will need to be have lifetimes of decades, and they need to perform. So we do a lot of spring characterization work, where that might involve adding flaws or defects and seeing how that might impact like fatigue life. But then we also will study, we recently had a project that involved irradiated cable wire and probing that strength and trying to prove out whether or not a cable had failed due to if it was hardened due to irradiation or not. We also we run the gamut from fracture testing, tension, we do compression. And one of the things about our job is that we get to work with a lot of exotic metals because of our mission. Principally, we're more interested in performance than price. And so we get to work with a lot of interesting materials like Hyperco, some titanium alloys like Ti 111 and 5553, some tantalum, some tantalum stuff. And we get some interesting engineering. We get some interesting engineering problems. One of our fun things to contrast and compare is every year when we have to fill out our taxes, we all wonder at, well, do I say my occupation as a research or as a scientist or an engineer? And I think it all depends on how that year went for you and what the types of projects you got involved in, because it definitely, as a research and development group, it can be either in mixed quantities.
Sure. Okay. Very good. Very good. Erica, could you give us an introduction, an overview?
Yeah, sure. So right out of my PhD, I moved to Wilmington, Delaware, where I spent 2 years at DuPont as a polymer engineering consultant. So I went from working on epoxies and structure property relationships to a lot of thermoplastic products, basically scaling up new polymer lines from lab scale to like warehouse scale, where the extruders are just unbelievably massive, designing the screws for that, troubleshooting existing product lines, things like that. I thought it was really boring. I wanted more hands-on experience, and so I started to look for something that might be more similar to the graduate school experience. So I was looking at postdocs and a bunch of different things, and I had applied to the position that I'm currently in now, which is as a staff member in organic material science. Funnily enough, Todd and I are in the same center and we work in the same building together. So even though we've got 13,000 people at Sandia, New Mexico, you know, it's kind of a small world. So I took that job and I started out working in polymer aging. So I was looking at combination radiation thermal effects on the cable insulation for nuclear power plant cables. So as they were trying to recertify the power plants, you know, for extra decades, cable insulation came up. I got some interesting projects on polymers in extreme environments, like, hey, Erica, we need a polymer to survive 500C for 15 minutes. That was interesting. Or looking at commercially available O-rings and their performance and degradation behavior in geothermal wells. So for geothermal technology, they're moving to hotter and hotter wells. They wanted to get an idea of lifetimes there. So that was a really interesting project. It was really cool. And the guys that are in geothermal that I met, man, they get to go all over the place. They get to go to Australia and Iceland regularly. So I'm super jealous of them. And then I did a lot more applied stuff for our weapons work. So the foundation of Sandia is to have a safe, secure, and reliable nuclear deterrence, meaning nuclear weapons. So I had a lot of work there, and it kind of like disappeared from publishing for a bit because you can't really publish on that. And then more recently, I tried to finagle my way into more fundamental research. And so we've got this internal funding mechanism called Laboratory Directed Research and Development. It's pretty competitive. I guess, you know, maybe 10% or less of the proposals get funded, and I was lucky enough to get 2 funded this year. So now I'll be working on some of my own ideas for self-healing polymers and some negative CTE thermoset material. So I'm back to epoxies again.
Okay, fantastic. That's great. That's great. So maybe we can open it up here to questions people might have, and if you could put your name in the chat box if you have a question, address it to me or everybody, and I'll be able to see that, and I'll call on people who have a question. And in the meantime, maybe it seems like at least a couple of you have made transitions from industry to national lab or industry to academia. Maybe you could elaborate a little bit on the challenges that came along with that and the benefits that came along with that. In any order, please dive in.
Am I still working?
You are, yeah.
Okay. Yeah. The one thing I'll say is, if you really want to be a professor, for good or bad, don't go into industry first. As I don't know if I'll be the only one, and people can say I'm wrong. There's still right or wrong. I'm not casting judgment on what people think, but you're dirty once you've been in industry. My path is not the path to take if you really want to be a faculty member. Doesn't mean it can't happen, but you'll have just made it 10 times as hard as it would have been. Do a postdoc for it's all cliche. Postdoc for a well-known powerhouse research group where you can publish a lot, and that'll build your resume in that direction. Anything is possible, of course, you know, but you know, that'd be my advice.
And Erica, how about you?
Yeah, I think, you know, part of when I was looking for a job, we had come out of the recession. It was only a couple years afterward. And, you know, my issue was trying to find a job for myself and my husband. And so we'd both gotten jobs at DuPont. It's definitely a different atmosphere. You know, everything there is really applied. That's not saying that things at Sandia aren't really applied. I certainly get a lot of applied work, but the ability to do research that I'm interested in and being able to do lab stuff, it's like I feel like it's a weird industry academia hybrid. And depending on where you're at, you can be very engineering heavy, especially if you're working on weapons products or you've got a tail number that you're working on, you know, very applied, very much like at the end of the day, you need to have a product and it's got to work, and it's got to work for decades, versus my organization, which tends to support those types of programs with materials work. Yeah, so it can definitely be done for sure to switch from industry to academia, and that happens, or sorry, industry to a national lab, and that happens pretty frequently.
Great, thank you. Okay, I'm hoping some questions roll in at some point. Let me go one further though here. For the students listening right now, so some of you have already touched about this, but what would your advice be for somebody who wants to end up, we already heard some of it from Jamie here, somebody who wants to end up in a position like yours, you're in academia or at a national lab, what do you think are the key points in your career and the kind of decisions you should be looking to make? Maybe Dave, you could go ahead and start.
Sure,
Thank you.
I'll chime in on this a little bit since I hire folks. So the first thing to point out on academic careers is there's not one right path for academia. As an example, I have students who've gotten their PhDs with me that are at R1 institutions and at kind of mid-level schools. And, you know, my most recent grad in academia is at Western Colorado University, which is a 4-year undergrad only school. And they got science and pre-engineering. And he decided while he was here that he saw the life we do in terms of research and said, I really like the teaching aspect. The research part isn't as cool for me. And he directed his career towards a 100% teaching institution. So academia broadly isn't just a monolith. If you're really interested in teaching, you need to tailor your experiences with that. Now, at the end of the day, most of the people that are at teaching institutions still came from big R1 schools like Minnesota. And so you're going to have a range of where you're applying for, and you need to think about what's the right thing to that path. If you want to be at a school like Minnesota, if you want to be at a school like Eastern Michigan versus do you want to be at a school that's primarily only undergrads. But at the end of the day, I guess my recommendation, if you're looking at a school that has a research component, be it kind of middle or big, the first thing to remember is you're not your advisor, and you're not going to compete with your advisor. And so you have to figure out, how do you stand out? How do you make you and not you be your boss's student? And that is often why you end up with things like going postdocing somewhere to demonstrate that you can be successful at multiple places. And then yet again, you have to demonstrate that finishing a postdoc, you're not just the postdoc advisor. So what makes you, and how do you communicate that clearly? You have to keep up papers, you have to publish, you have to make sure that the stuff you work on is important. It's not just the quantity, it's the quality and the quantity. And quality should not only be measured by metrics. Impact factor is a poor excuse for goodness of a paper if you can articulate its importance. But if you ignore things like impact factor, when you're one of 200 applicants, the first thing that a committee looks for is a reason to stop looking at you, because they have 200 people to go through. And so they look for anything or any flaw to say, let's out. I want to concentrate on these 20, not the other 180. So your first job is to not be in the 180, which means things like impact factor matter a little bit, but do not think that somehow that's a magical panacea and the road will be paved with gold and there'll be unicorns and rainbows dancing around because of your wonderful paper in a high impact factor journal that has one name. That's not necessary. It doesn't hurt, but it's not necessary.
Okay, very good. Jamie, would you like to weigh in?
Yeah. No, don't be shy is one thing I would say. And Dave said, yeah, you don't, self-promote. So if you're shy, and also if you're shy and you're not self-motivated, you're going to usually end up in the 180. you have to, even if that's not naturally your personality, and I guess as most PhD scientists, I guess aren't me. I'm a loudmouth former football player. And I don't expect you to be me. Be yourself. But when you're applying for jobs, even if you have to be uncomfortable, self-promote. If you think you're great at something, even quietly in the back room, say it out loud in your application. Any humility is only going to work against you. I mean, you don't have to necessarily be over the top, but be bold. And everything in life goes along with I have like 3 things I tell my grad students all the time. One of them is you don't get if you don't ask. That's it. Nobody's going to magically just see how great you are and just give you something without you asking for it. That the world doesn't work that way.
Okay, very good. How about a national lab perspective? Erica or Todd?
Yeah, I'll say you guys are lucky at Minnesota because you're one of our target schools for Sandia. And Todd and I happen to be recruiters for Minnesota. So one thing for the national lab is when you go to our website or careers website, you can set up notifications when jobs pop up. Do that. Do that if you're interested in it, because the sooner you can get in there, the better for you. One caveat is that because we do national security work, we do work on nuclear weapons, you have to be a U.S. citizen for a majority of the positions. So just keep that in mind. But, if you do apply or you see something, you can reach out to Todd or myself. I'll help you with your resume and tailoring it. I can introduce you to the hiring manager. Because you're a target school, it makes it a little bit easier for us to try to find something for you and at least get you an interview.
That's great. Actually, so we have a whole bunch of questions now. So let me move on a little bit here. And Rain Francis had a question. Maybe I can call on Rain.
Hi, everybody. Thanks for being here. Good to see everyone. We had a panel like this a couple weeks ago, and they were folks from industry, and they were talking about new products that they were launching, and that was one of the rewards of their careers. And so I wonder, from your perspective, and national labs and university life, what are the rewards of your career choice?
Okay, who'd like to? Dave, are you ready?
Yeah,
Sure.
I thought Erica said something, and then there was a delay, but maybe it's not. Maybe it didn't come.
Yeah, I think
there's a delay on video.
Okay.
Yeah.
Yeah, sure. I'll go ahead and take a stab first. So for me, probably there's 2 things that I enjoy. The first is I have the ability to feel like I'm taking risks without actually taking some of the risks. I realize that a lot of faculty would be really good people for psychologists to examine. My father started a company when I was in like 7th grade or something. And I remember him driving a taxi during the night while working on getting clients. He did heat treating and environmental remediation. And he was an engineer, and he was working, getting clients during the day and driving a taxi at night. So in retrospect, we could do frivolous things like eat. And of course I was in 7th grade. So that wasn't that. I did not realize at the time, like, oh, wow, that's like a really big risk. So what I did was I picked something that had the trappings of the coolness of, I get to work on these exciting new innovative things where I get to make the direction, but I picked this giant safety net that comes with it so that I would never have to worry about eating. And so I think that for me, that it's that ability to get to try things that can be really risky in academia with knowing that I still have a job. That aspect is, I probably am a little messed up from seeing what happened when I was in the 6th, 7th, and 8th grade kind of time frame, formative years of career choice. The other thing that's really appealing for me is getting to live vicariously through others. I am never more happy than when I see a student get to do a thing they want to do, even if it's not something that I have absolutely no interest in doing. So Hector, who again is teaching at Western Colorado, I would not want that job that he has. He, by the way, also hates snow. And so being 20 minutes from Gunnison's probably, or 20 minutes from Crested Butte's a really bad career choice for him, but many people would say that's kind of cool. But it's what he wanted to do career-wise. And so I was really happy that I could make that happen and help him develop in that way. So I like living vicariously through others with a big safety net. That's the enjoyable part.
Very good.
For me, I think one of the biggest thing is traveling and just, I don't have kids, so maybe that's easier for me, but I've made good friends all around the world. The best collaborations are some amount of scientific overlap, but to be honest, if you don't have a good personal relationship with your collaborators, it won't be a good collaboration. So you would take less of the science and more of the, you enjoy hanging out together. That makes for a good collaboration. And so, being in Paris one week and Tokyo the next week and Sydney, and it does wear you out, but life is short. So yeah, I live the life of a rich person without being rich. That's what I say sometimes. It's not totally glamorous. It wears you out and you do get stressed. And Dave said something about a safety net. Purdue must be a different school than A&M because we have no safety net. I have a guaranteed 9-month salary. I think that's the safety net he's talking about. Short of that, I have zero safety net. Nobody's paying for my grad students. Nobody's paying for if I don't raise the money, we're dead. And that's most research schools. And I can live with that. That's the price I pay for complete freedom. If I can raise the money, nobody could care less what I'm doing every day. I could be studying beetles or some social science thing, and they probably wouldn't care if I could raise the money for it. So I mean, it sounds cutthroat, but it's wonderfully free at the same time. So yeah, that's the reward. Freedom / travel for me.
Okay, great.
I could chime in here a little bit. For me, one of the great things about working in the national lab, when I first showed up for my interview, it very much felt like I was back in Amundsen Hall, walking down the hallways. It has a very academic vibe, but when I get into the lab space, oftentimes we don't have to worry about funding. People come to us with an emergency situation they need solved, and they will give us the money to think creatively. And a lot of times that generates, unique solutions to these problems, and you get to think. And we're in the sort of unique situation. We actually have a machine shop in our building, and so I can get down there and I can actually make the things that I want to do and to test and design. As a material science major, we got some drafting skills, but I think in my personal career, like my ability to draft and design components has expanded a lot just because people come to me with ideas, and that's one of my personal interests, and just kind of like the inventorship of the job. Just 2-3 weeks ago, I was granted I was co-inventor on my first patent for topological dampening metamaterials. So imagine a lattice material that has internal structures that are completely at your control because it's 3D printed. So you can control where deformation happens. You can control natural frequency and resonance. And just looking at that patent and seeing my drawings and the data that I collected was just a huge source of inspiration for me. And to realize you have kind of impact like that beyond what you thought. And honestly, I did that work within my first year at Sandia. And 4 years later now, it's finally kind of coming to fruition. And there was a lot of people involved in it. It wasn't just me, but to see that kind of impact on something you worked on 6 months out of college is very eye-opening, I should say.
Yeah, that sounds phenomenal. Yeah.
All right, I'm back. I was having issues with my work computer, so we're on the
Okay.
iPad.
Great.
So I'll say, for me, the impact is, because we work on like national security problems, and a lot of it, we can't talk about, but knowing that I'm having an impact on something that affects all of us, is, a really big motivating factor for me. We're allowed to get patents. We get some royalties from those if they're licensed. We get money for filing patents, which is nice. Even, just being able to publish is great. Now that I've got, those research projects that I can actually publish on, that's also a reward as well. But yeah, I think the biggest reward is knowing at the end of the day, the stuff that I'm working on does have a real impact for the nation. And so, even though some of the stuff is very fundamental, but knowing in the long run, this is going to have a certain impact in this area is really like a big draw for me.
Yeah, fantastic. So let's take a question from an undergrad. Maybe I can call on Andre Bone, and he can give us his question.
Hi, I wanted to ask a follow-up on what Professor Barr said earlier about the possible tracks of being like going into academia as a researcher or just as a professor. Do you see a big difference in like the market for those two positions? Is one of them more valued or more competitive? And is it possible for someone to transition between the two at a certain point in their career?
Sure.
Okay, great, Andre. Thank you.
So another phrase I like to use is that different does not mean better or worse. It just means different. So I don't describe value in terms of goodness and benefit to society for just based on size and ranking in the university. Texas A&M, Purdue, and Minnesota will fight tooth and nail and scratch and brag about what rankings they have and who gets to poach who from what university and how many grad students they have. And, two of the three of those institutions don't worry as much about football. Looking at you, Jamie. But I think that the key is that it's about personal satisfaction, and they're just very different jobs. It is very difficult if you're at a primarily undergraduate institution, PUIs, to move to a research intensive institution. That's going to be an uphill battle. Moving the other way has some real concerns too once you've been there for a while, because people ask why you're doing it. They think you're going to come in, be kind of uppity, you'll be not ready to do the hard work in the classroom day in and day out, because I'm guessing that the teaching schedule that you're used to for Minnesota or Texas A&M or Purdue is very different than four courses a semester, which you might be at a fully teaching institution. So it's really that they're just different. And then every school is going to have a spot where it has, what's that balance between teaching and research? How much do if you're an undergrad place, it might be a private school that really expects investment in the undergraduate research experience versus people at a large state school who's, state school that has a large student population, but it's mostly part-time, non-traditional students. That's a very different experience. So where Jamie was teaching California on part-time teaching gigs is going to be a really different experience than at a big school. So it's not impossible to move between things, but the people looking at your resumes, particularly because it's competitive, will often apply their biases towards, they don't really know what they're getting into, or that won't translate well. And then that again comes down to, how do you articulate why you're the right person for this job?
Great.
No idea if that actually helps or not, but it's my 2 cents.
It helped. Thank you, Professor.
Jamie, do you think you could also comment on this one?
I forgot what the question was already. What was the, Andre, what was the question?
Yeah, go ahead, Andre.
I asked about the difference in competitiveness between seeking a career in academia, focus on research or focus on teaching. And how the transition between those at a later point in the career.
Yeah, I think the competitiveness. Maybe I'm just going to rephrase what Dave said, but yeah, I think the more highly ranked undergrad teaching only school is going to be more competitive than the less highly ranked undergrad teaching school, and the same thing at the research school level. I think that's kind of what you said, Dave. It's not so much. There could be 300 applicants for what's a really ritzy undergrad only, Williams College or something. Although I don't think they have engineering, but that'd be for chemistry or something. But Rose Holman in Indiana, not too far from Dave, one of the best undergrad engineering, or Cal Poly San Luis Obispo, or Harvey Mudd or something like that. I guarantee you that's just as hard to get a job. Not guarantee, but because I don't know, but I'm pretty sure it's just as hard to get a job there as it is at Minnesota or A&M or whatever. Totally different job, but and then it'd be easier at Podunk, middle of nowhere, Iowa, four-year school that nobody ever heard of, and I'm not hurting anyone because I didn't name this. I don't know the school that I'm talking about. It's a made-up school. I should have made up a state. I don't care. But regardless, Texas has a bunch of Podunk, middle of nowhere schools. It's less competitive. Although if you don't have a good resume, you're not going to get a teaching job. Period. So it's competitive at any level, but certainly the less the ranking, probably the less the competition. Crudely speaking.
Okay, great. I think that's a very thorough answer there. So we have a question also from an undergrad student, and I'll read this one out, and it's more focused for National Lab people, so for Todd and Erica. And the question is about, this person's wondering about how salaries compare at national labs compared to sort of equivalent positions in industry, maybe at the same sort of stage of development past graduation.
Yeah, I can talk about that one. I'll say, like, we don't have a very large technical ladder. I got promoted this year, and most people only make it to this promotion. There's caps on who can get promoted to what position. I will say the salary is competitive. I think the benefits were better for me here than they were at DuPont. The cost of living is a little bit better. You're not going to get into the regime where there's going to be a ton of promotions and those opportunities to, get those big salary increases and big bonuses. It's just, yeah, at some point there's going to be a divergence where industry is going to win salary wise from us. But I've got job security, which I like. I think we laid off people at one point ever and then rehired them all at some point. So really, really good job security, which you may not get in industry.
Yeah, and to piggyback on what Erica said, Sandy is a federally funded research and development center, which means that we are contracted to the Department of Energy, but we are, because of that status, we're somewhat immune to federal government shutdowns. So in the past 4 years, I think there's been at least one pretty lengthy shutdown that we have our own budget. We were completely immune to that shutdown, which to some people we didn't get furloughed in the end, or furlonged, or whatever they say. We didn't get our back pay for the month that we couldn't come to work, but we didn't have to worry about it for that month either. I agree with Erica that the potential for raises isn't as crazy as it is in industry, but for a technologist, we are hourly workers. We work 40 hours a week and we get to go home. In private industry, you could be asked to work 60 plus hours a week and hope that you see some sort of compensation at your yearly bonus. And for me personally, the work-life balance here was a critical component in considering and accepting the job. And the cost of living in Albuquerque, New Mexico is also a component. My wife is able to stay home and raise our 2-year-old son because I have a full-time job at the labs, and we live a comfortable life. I'm not traveling all over the world, and we're not going on crazy vacations, COVID or not, but it was an important consideration for me. And I think the work-life balance here at Sandia is a step above what you'll find in private industry most of the time.
Yeah, I'll say, we tend to get more vacation too. I do think the benefits packages tend to be better. And when I had my son, I took 20 weeks off, and it was like a non-issue. My manager's like, whatever, I don't care. Take as much time as you want, kind of thing. So I don't think I ever would have been able to take that much time in industry.
Okay, fantastic. Dan Frisbee has a question. Maybe I can call on Dan.
Yeah, I'm really enjoying this discussion, and I kind of want to piggyback off of Lorraine's question. She asked you about rewards of your careers, and I think one of the things that I find graduate students are wondering about when they think about going to academia and to some extent to national labs is they worry about proposal writing. There's maybe a bit of fear of thinking about, well, what am I going to, how am I going to do this? How am I going to write proposals that fund my whole research program and give me summer salary? So I'd like to hear from each of you how you approached that, to what extent it applies in national labs. I think it does to some degree. But just from each of you, how you kind of approached your first proposal and thought about that whole process.
So
Sickness and dread is how I started. I still to this day hate proposals. Worst part of my job. I don't know if I'm the only one who thinks that, but because I can't even publish it once I write it, but you were probably afraid of writing a journal paper at first too. And it's one of those things you look at other people's examples that did a good job and try to follow what they did. Not follow their idea, but structurally how they organize it. You'll learn from, just like you learned when you write journal papers, how to write a journal paper. You looked at other people's examples. You do have to think of some ideas, or at least you have to have some students with good ideas. I don't know, or whatever. But it's probably not much worse than writing a journal paper. The thing is, though, the acceptance rate for journal papers is much higher than the acceptance rate for proposals. So be ready for a lot of rejection, and that you just have to get over it. It sucks the first couple of times, but I mean, you actually you just get used to it. So it is what it is.
So I'll say the way I phrase this is there's work that pays the bills and there's work that you like doing. And it's nice when they're the same and you still need to pay the bills. And so when you can't do just the parts you like. If you only do the parts of the job you like, it's a hobby. You get paid for the parts you don't like. And writing proposals is a part. I agree with Jamie. I don't think a lot of people love the proposal writing, but it's part of what you do so that you can do the other parts. And I think for people starting out, my recommendation is you follow the Oakland A's approach, right? Play small ball. You write a bunch of little proposals. I've seen faculty start off and try to write only the really big ones to start. So find those things like the ACS, Petroleum Research Fund, the 50K kind of things as a faculty member. And, 3 years from now, 3 years from a starting faculty position, some go, but I spend as much time on that as I did on my big career grant. I'm like, right, but you are a lot better at it, the bigger one, because you went through some of the small ones. So hit a few small balls first before swinging for the fences. And grow some thick skin because you need it.
So where I'm at Sandia, because I'm not, I don't have one time charge code. I've got like 8 projects going on. I have to write proposals. A lot of my stuff is just networking, and the more you establish yourself, the more kind of work just falls in your lap. But I've got to fund myself. I've got to fund technologists. I've got to fund my postdoc. And it ends up being, close to $1 million a year because we have ridiculous overhead for staff members here. But I just dive in, just do it. ask people for feedback. One of the things I think I really got out of Minnesota was learning how to give and get feedback. The more that I review proposals, for NSF or even just journal articles, I guess you get a better understanding of, what the competition is like, how people are writing, how they're presenting ideas. And then for me, it's walking a fine line. And this is kind of where I struggled with initially was, Frank always told me to underpromise and overdeliver. And so just how do you straddle the line of selling your research, but not overselling it, so that at the end of the day, when I'm done and I'm going to present to my customers or whoever I'm getting my funding from, that they're like, wow, she did a really great job, and they're willing to give me funding again in the future. So just dive and just do it. I mean, I'm the oddball. I like writing, so I really don't mind writing proposals. At least the smaller ones that are a little bit more manageable. But you're not going to, get rid of that fear if you don't just do it.
Yeah, great perspective from everybody. Thank you. We have a couple more questions. Maybe I'll call on Zach Cresswell.
Yeah, hi. I had a question about, I guess it's kind of similar to Professor Frisbee's, but the nature of the research in academia versus a national lab. How much control do you personally get to exert over the direction of your research, and how much is, I guess, determined by whatever funding agency you're drawing from, and how does that differ between the two career paths?
Okay, great question. Who'd like to dive in first?
Sure, I'll dive in.
All right, great.
Yeah, so for the funding sources, a lot of it comes from my internal customers, and a lot of it comes just from basic DOE money. I don't often apply for outside funding. There's a whole part of Sandia that wants you to do that, or that you have to go through to do that, to make sure that you're aligned with proposals and stuff. But most of my funding is going to be internal and just kind of a word of mouth at this point. I don't know how much that differs from academia, or if I answered.
Erica mentioned this earlier, and it's the LDRD process, and that's kind of an internal pot of money that you apply for, you propose for, and that comes from an internal budgetary supply, and it is highly competitive. There's multiple rounds, but that is something that you are interested in entirely. So if you have an idea of something you want to research, you write your proposal, and hopefully you survive the 2 or 3 rounds of down selection, and that's almost entirely your idea. And once you secure that funding, you will have 1 to 3 or some number of years to pursue those goals. There's collaborations with universities. There's even collaborations with small businesses. Sandia does occasionally spin off technology into a small business type agreement to stand up something that's maybe less useful for our particular mission, but still has value in the commercial world. One project I was involved with was this, they called it al instante, which means in an instant, but the idea was that you would have a robotic assembly line of materials characterization equipment, and you would pass this specimen array through multiple different characterization techniques, including tensile testing. So this is primarily for additively manufactured parts, but things like density and chemistry can also be done. And after 3 years, their funding ran out, and they decided, especially now with all the work from home stuff and the human contact concerns with viruses and pandemics, it was spun off into a small business. So those, like, you have the potential, and there are several success stories, if you want to call them that, of Sandia scientists leaving Sandia to become CEOs of their own company based off of research and projects that they developed.
Yeah, I guess the moral of the story is, when you start out, you're going to take whatever you can get. And then as you become more established, you get to pick and choose what you want to work on, right? So if you're not networking, you know, at the labs, then you're at least in my organization and Todd's organization, you're going to be dead in the water. You've got to do good work, show people that you can be trusted. And then you start to get a little bit more leeway too. And just like, hey, I've got this idea. It's tangentially related. You want to throw me like 100K in, you know, 6 months and I'll work on it kind of thing. And then you start getting funding for that. So at the beginning, you just take what you can get, pay the bills, do good work, and then, you know, branch off and do what you want to do, as long as it's related somehow to a mission.
And I'd say from an academia standpoint, the thing to remember is that the funding agents, you know, we write proposals to different agencies, federal, state, we write to companies, and it's about knowing your customer, right? So if you're writing to NSF, you're going to be having, you know, something that probably ties into broader impact and educational development. If I write that stuff to DARPA, the laughter rings out long and hard because they just don't care about that. So you'll learn who your customers are and how to approach that part of, you know, balancing that line of paying bills and doing what you like doing, and just recognize that not every idea is gonna, not every potential customer is gonna bite on every idea.
Very good. So we are going to run out of time, unfortunately, but maybe we'll try and squeeze in one last question. There's a question from Daniel.
Hi, thank you all for such a great panel up until this point. I guess my closing question is specifically for everybody, because you're writing proposals and running research programs. Being academically inclined myself, I asked my undergraduate advisor, you know, what distinguishes someone? You know, at that point, I guess everybody's a subject matter expert, but how do you become someone who's going to lead the field? How do you develop a stable, secure research program? And the thing that he said the most was that you have to be good at like seeing broader trends in fields, and also marrying not only expertise, but also salesmanship into how you present your ideas. And, you know, beyond just the raw exposure that you get as a PhD student, I'm curious, like how during your respective career processes did you build skills of connecting the dots in your fields and seeing the bigger picture and seeing, you know, what's a hot area of research, and also then, you know, tuning your own trajectories to be able to sell the views in alignment with you, I'm so sorry, in how the field is, in the direction that the field's going in.
All right, this is a great final question. Who'd like to go first?
I can take this one too. Read.
Great.
Read journals in your field, read journals not in your field. I get a lot of inspiration from like just really random papers that just from reading a lot, I can come up with new ideas. If you're not reading, you have no idea what's out there and what the newest technology is, or whatever the new research is. So read, even if you're just reading an abstract and saving it for later to come up with something later, or to get more in depth with it. But read, and don't just limit yourself to your field, because a lot of my innovation, like I said, just comes from reading articles that have nothing to do with polymer science whatsoever. So
I'll just second that. The Reese's peanut butter cup ideas are the ones that win. So when you mentioned about an area that's hot, if it's hot, it's already crowded, that can be a hard place to play. And the really interesting spots, and I think where the biggest bang is when you realize you're good at something and you realize somebody else is good at something. And if you put those two things together, the sum is, you know, the whole is greater than the sum of the parts. So look for those kind of opportunities.
I'd say, yeah, look at offhanded. The other thing is offhanded suggestions. I probably have a bigger industrial portfolio than a lot of faculty do. For good or bad, and I got into flame retardancy, which is probably my biggest moneymaker right now, because just some scientist from Boeing wasn't funding me, just happened to be visiting A&M and sat in my office and said, "Oh, you're doing these gas barrier coatings, but they have clay in them, and that looks like stuff that might be flame retardant, and we're always looking for new flame retardant treatments and stuff." And it sounded like the dumbest, most boring thing I ever heard in my life. And the flame retardant field is considered like this kind of boring field, but I was naive and young and hungry, and I coated some stuff, composite materials, and one thing led to another, though. And we were talking about, Dave mentioned impact factor. It isn't everything. It is superficial, but both students and professors like to have covers of big journals and things. And I will say, if I made any big impact in the world, it was I made flame retardancy sexy again. Because when I published I had a cover of Advanced Materials, and the whole, I got tens of emails from major people in the flame retardant community that just couldn't believe just that I published in Advanced Materials on flame retardancy, because it was considered such an old, boring field. It'd be like cold working of metal or something. I don't know if anyone's researching that. I apologize if you are, but I'm in one of those boring old fields anyway. You can twist something. That's so kind of like Dave said. Also reinvent something. I don't know. There's no magic though. A lot of it's, I say, blessing, just because. Yeah, I mean, in my life, it's not me. It's other things beyond me that are helping me. So, yeah. Period. I guess I'll say. Oh, can I say one thing though? Since we're finishing up, we didn't get to say about Minnesota and what Minnesota did for us. That's what you asked us, Chris, or Gail was actually the one who sent the questions. I did want to say, Lorraine's on here. Lorraine was my advisor. You thought she was a grad student when she asked the question. Everybody in the audience maybe thought it was a senior grad student, but that was my actual research advisor. And I learned to write and to do science. And I mean, truly, I was just the dumb football player, and really got chiseled out by very good advising from the faculty at Minnesota. It's really the top faculty in the nation. I don't care about the rankings, although they're highly ranked too. But the bottom line is, I got my foundation at Minnesota, and so Minnesota will always be an awesome school in my mind that I'll always be cheering for. Of course, if we're playing football against you, I guess I don't have to worry about it anyway. But then I'll want to spank you. But otherwise, yeah, you're at a good school. Any of the students in the audience, you're at no deficit compared to MIT or Stanford, or name another thing that you think is awesome. You're at an awesome place, and you'll have no problem if you are a hard worker doing good work. All right, now I'm done.
Great
Yeah.
for our students to hear. Awesome.
Yeah, and I'll echo on that. I feel like I've pivoted a lot in my career, and I couldn't have done it without having the fundamentals that I got from the department. I couldn't have gotten there without being able to learn how to give and receive constructive criticism. That's a hard one to take. And just learning how to, hold yourself to a really high standard, because I think every professor at Minnesota does do that. And our department definitely holds it to a high standard. I'm, looking at a paper I'm trying to write now, and I could probably publish it in a journal, but I'm looking at it like, this just isn't good enough for me. And so I think, I thank Minnesota, and I thank Lorraine, and I thank Frank for setting me up to have that, self-criticism to want to do better.
That's fantastic. Unfortunately, we are going to have to cut it off. We could have gone on for a good while longer, I think, and that was really fantastic. I thank you very much for coming, everybody, to listen to this, and the panelists as well. I hope you can virtually join me in thanking them. I thought that was a very insightful event for us to have. So thank you very much to everybody for coming and joining us.
Thank you.
Thank you, guys. That was tremendous. Thank you so much.